what was wrong with my computer today, but let me share the screen with Aria's work. Okay, Aria, we can't wait to hear you then. Yeah, please move on.
Okay, wait a moment, teacher. Uh, my presentation is very short.
No worries.
Dimensions and chance.
It seems I'm doing nothing.
Um, so hi everyone. Today I will talking about the radioactive decay modeling. Teacher, please move to
Next
the
slide.
next page.
Sure.
Thank you.
No problem.
So the first part, I will introduce the radiation therapy, and it means cancer treatment has many kinds of treatment. Some people with cancer will have only one treatment, but most people have a combination of treatments such as surgery with um, chem- chemotherapy and
Chemotherapy, huh?
radiation therapy.
Uh-huh.
And the picture shows us the types of cancer treatments.
Oh,
There
okay.
are 7 types,
Oh,
such
wow.
as surgery, radiation therapy, and there are 7 types.
Oh, okay.
And
To be honest with you, I never look at the type of the cancer treatment in that broad way. That notice that we have stem cell therapy. Interesting. That's the thing which I learned today. I never knew that stem cell therapy, they just do that for the cancer, which it means that my understanding is too old fashioned now. That I knew about the radiation therapy, chemotherapy, immunotherapy, hormone therapy, I knew that, targeted therapy, I knew that, and stem cell therapy. Interesting.
uh, and the teacher, can you move to the next page?
Give me 1 second. Stem cell therapy. Oh, okay. Give me 1 second. I'm taking some notes, Aria.
Okay, okay.
You
Uh,
know,
I this time I put the reference and the links on the last page.
awesome. Thanks. And immunotherapy. And okay, let's go. Aria,
Yes.
I'm on the next slide.
Okay. Thank you, teacher.
No problem.
Now I will talking about the definition of radioactive decay. And the radioactive decay, also known as a nuclear decay, uh, radioactivity, radioactive disin-
Disintegration.
disintegration or nuclear disintegration is the process by which unstable atom, atomic nucleus lose energy by radiation. And the picture shows us the definition. And the therapy that use a radioactive substance that gives off a type of high energy radiation called an alpha particle to kill cancer cells. The radioactive substance is injected into a vein and travels through the blood and collects in certain tissues in the body, such as areas of bone with cancer. And in order to estimate the amount of radioactive material left inside your body, we need the concept of half-life. It is the time required for half of the atoms of a radioactive substance to become disintegrated.
Disintegrated.
yes.
It's so hard to pronounce it. I had some,
Yeah.
when I was learning English, I had the problem myself to pronounce it.
Yes. Quantity of real reactive um, material life could be estimated from the third formula above if we know the half-life for it. It is well known as exponent function from mathematics modeling.
You mean the exponential decay function, huh? That's what we
Yeah,
covered, huh?
yes.
Oh. Then Aria, you said that then the kind of treatment as a radioactive treatment for the cancer therapy is that they're using the alpha particle of a radioactive decay in order to treat the cancer, huh?
Yes.
Okay, okay, nice, very nice, very nice. Okay,
Thank
next
you.
slide you want?
Yes. And now I will introduce what is the half-life. The half-life of a radioactive substance is a characteristic constant. It measures the time it takes for a given amount of the substance to become reduced by half as a consequence of decay, and therefore the emission of radiation, radiation, radiation. No. And the um, the first picture is a graph shows us the half of the original amount and a quarter of the original amount. I just searched two data to show us the
That's
information about the half-life.
It's very interesting. It means that, for example, at any time when you start with any given material, for example, it can be 1 pound, 2 pounds, half a gram, or anything. After that constant, which is a half-life, the amount is going to be reduced to half.
Yes,
After another
and
half-life, the same amount is going to be reduced to half. One, 1/2, 1/4, 1/8, 1/16.
yes.
But Arya, my question is that does it ever get to exact zero?
Um, exact zero?
I mean, the amount of the material, imagine that you start with 1 pound of a radioactive material. And you know that, for example, half-life of the material is, for example, let's say, for example, 14 days. Every 14 days, for example, it means that 1 pound of that radioactive material after 14 days becomes, let's say, half a pound of the materials. Is it possible to have all the materials be consumed and become zero and we have nothing left?
Hmm.
We have to think of it as an asymptotic behavior of the exponential decay modeling. Do you remember when we talked about the asymptotic behavior and let's say endpoint behavior? We said that we may get close to zero, but we never reach to the zero. Huh?
Yes.
Yeah, nice. It was a good thing that we remember the things which we did maybe how many times, how many, maybe over 3 months ago. Oh my God, it's too long ago.
Yeah.
It's it. Thanks for incorporating that slide because it forced us to review something which we studied many, many times ago. Thanks for refreshing our memory. Thanks. It was great. Okay,
So it's never. It should be never equal zero.
that's right. It
Uh,
asymptotically reaches to zero, but never reaches to the zero itself.
okay, I understand. Thank you, teacher.
No problem.
Please, teacher, can you
Next
please to
slide.
read the next?
Sure.
Thank you. And so next, we have radioactive decay formula. Below those three pictures. This, the first formula requires decay constant, and the second formula needs half-life, and they are equivalent. equivalent. And the first formula, it shows the decay constant. And N means the number of atoms remaining.
That's right.
And N0 means original number of atoms. And the E means the exponential number. And next is the decay constants, and T means the time. I'm talking about the first formula.
That's right. And you said the note here, in order to determine how long does it take to reach a specific remaining amount, that's right. We could apply logarithm functions to remove of the exponential and you express in terms of the logarithm function. Then what is the difference of the left equation with the right? Oh, I got it. That's the half-life.
Yes, it's a half-life.
That's right.
The right one is the half-life.
Oh, that's right. I
They
got
are
it.
different. Yeah.
Yeah, that's so true. That's so true. That's so
Yes.
true. Interesting. Good equations to include in your presentations. Good equations.
Yes.
Thanks.
And so in order to determine how long does it take to reach a specific remaining amount of the radioactive material, we could apply Lorentz, which is the inverse conclusion as exponent.
That's so true.
And the third part, the third pictures shows the formulas, many formula.
That's right. I think that formula is very interesting because also we didn't cover that in the class, but it's good that you brought it. Thanks, Aria, for it. For example, look at that on the equations which you have, which is the one on the right. What did you do was that you wanted to see how long it takes that you, for example, the amount of the material that you started with, and how much that you are ended up. For example, you started with 100 gram, now you have, for example, 80 gram. Let's see, what is the half-life? You have the N, you have N naught, then you divide both sides of the equations by N naught, then you get NT over N naught equals to 1 over 2 to the power of T divided by T, which the T is the time that you're looking for. And the T is the amount of time that is elapsed. And essentially, then it says that what? You take a logarithm from both sides. You see that on the third line. Then you use the logarithm's law that you say that, okay, I can take the exponents as a hat, take it back behind the logarithm. Then you have these, I should say, these expressions. Then you divide both sides by the log of 1 divided by 2, which is a negative number itself. Then you get what? You're looking for the T divided by T. Then you multiply both sides by the T, which is the half-life. Then you take the time which has elapsed to get that amount of the material. It means that if you are with this equation, you're looking for the T, then you have to convert the image to the logarithmic function, which we talked about that extensively during the time that we were looking for the logarithmic equations and the logarithmic representation of an exponential function. Fantastic. Thanks a lot, Aria, for including those mathematics there, because it helped us to learn something new and refresh our mind from the things we did in the past, that it may show up in your final exam. Thanks. Next slide.
Yes. This is the last page, and I put the links that I searched.
Oh, fantastic. Very professional to include. Thanks, Aria.
Thank you.
Great presentation. And thank you for also including, I should say, these the slides and also these mathematical equations, because that's essentially the modeling that you were talking and looking for into radioactive decay. And also thanks for including the information that for the cancer therapy, we are looking for the alpha decay of the radioactive material and that's what used for the radioactive decay. Thanks a lot, Aria. It was a great presentation, very good information. Thanks a lot for it.
Thank
But
you.
however, Aria, I
Yeah.
have one assignment for you.
Ah.
In case if you are willing to do that, how many presentations you have had so far?
I already do the 2 presentation.
Two presentation.
Yeah.
Some of the people here, like for example, Sean and Mingjae, they have done 3 presentations.
3?
The third one, I'm gonna tell you what's gonna happen. The third one is not mandatory. You do not need to do that. It's not part of the marking schemes for the class.
Okay.
If I suggest you a third one, depending on the questions which you raise in your presentation, you can get additional 10% of your final exam. For
Oh,
example, you write your test, you become 75, for example. For example.
okay.
Then I added all your presentation, all your homework, your midterm, your final exam. You are given 75%. Huh? Then I'm going to report 75% to the office. But if you do the third presentation, depending on the quality, you can have up to 10% on the very top. Then I add, for example, if you did a great job, you get
Yes.
10%. Then you get 85%. That's
Wow.
the 85% reported to the office. Do you want to do that or no? You're happy with the first 2 presentations?
I want to do that. I want to get high mark.
You want to do the third presentation?
And yes.
Yeah. Then this is going to be the topic for you, and you can do that either on Monday or Tuesday, which
Okay.
is going to be this one, which you had it on your presentation, which it raised so much curiosity. The stem cell therapy. You see this slide which I have here?
Sorry, teacher.
You see this slide which is shared right now? This is your slide.
Yes, my this lab.
You see this stem cell therapy?
Yes.
I want you, Aria, please
Yes.
do just research on the stem cell therapy. Please include as many information as you can and search to see if there is any mathematics behind it, and give more pictures, more demonstration height works, give more slides and more presentations, more slides, more pictures, more information to see if there is any mathematics describing the stem cells. Maybe stem cells can be modeled by a math equations and how it works with the cancer therapy. Please include, if you want, include as many information as you can, do
Okay.
as many research as you can, and come on Monday or Tuesday. Let me know which one you pick with more slides, with more information. Then it adds you, depending on the quality of your work. If you have more information, you can get 10%.
Okay.
If you have few information, you may get 8%. You know, it's 10 maximum. Then on
I know.
Monday or Tuesday presented, then it guarantees additional 10% on the top of the things that you are done in the class.
Okay.
If you get, for example, 90 on the final exam, then I add 10, then you get 100.
Wow.
That's right. Are you willing to do that?
Yes, I want to do that.
Okay. Then which one you pick up? On Monday or Tuesday do you want to prepare for it?
Maybe Tuesday?
Tuesday?
Yeah.
Then Tuesday, we are gonna go with that thing with the Aria presentation on the stem cell therapy and the possible math behind it.